Now let's look at some of our other properties of exponents. Nothing changes just because they're rational exponents. If I have 3 to the 1/5 times 3 to the 3/5, just like if I were to have x to the 5th times x to the 7th, this is when I would add exponents. It's not going to change just because it's fractions. When I multiply those, I'm just going to say 3 to the 1/5 plus 3/5. 1/5 plus 3/5, 4/5. I already have a common denominator. If I didn't, I would just have to get a common denominator, and then I would just add the numerators. Now, it's important, remember how the x didn't change? It didn't become x squared. I'm not going to say 3 times 3 is 9. Remember, this only works when it's the same base, and the base needs to stay the same. Nothing changes just because it's a fraction exponent, but with a fraction exponent, if I needed to, I could put right back into radical form. 5th root of, swing the denominator around as your index, 3 to the 4th power. If they ask you to put it in radical form, there you go. Well, same thing when I have quotient of powers, a to the 1/4 over a to the 1/2. When I see these examples, what I want to do are quotient of powers, just like if I had x to the 10th over x to the 7th, I subtract exponents. Well, even if they're fractions, subtract exponents. A to the 1/4 minus 1/2. In this case, I would need to get a common denominator first. Times 2 gets me a common denominator of 4. A to the 1/4 minus 2/4. Once I have a common denominator, subtract the numerators. A to the negative 1/4. Well, what do I do with the negative exponent? Take a reciprocal. This is going to be 1 over a to the positive 1/4. Throw it to the bottom. Make it positive. Don't take the reciprocal of the exponent. Take the reciprocal of the term. And what I would say here is 1 over, by all means, swing that 4 around as my index. The 4th root of. I could say a to the 1st, but a to the 1st is just a. And there's the fully simplified answer in radical form.